Hello everyone. Hello everyone. Today we are going to discuss about the Hello everyone. Today we are going to talk about the good evening to everyone. So finally today we are going to discuss few questions based on the basic principles of organic chemistry 2. So very good evening to all of you. And right now we are going to talk about the few reaction based questions and few GOC based questions. So let's have a look how this NEET usually ask questions from the reaction based questions and the GOC based questions. Questions you will find that it won't be very much difficult. Only few things that you need to remember it. Basic principles, not a very big deal. All questions are coming most of the time NCRT. So let's have a look one by one. So this is the first question that you are going to see. Which among the given molecules can exhibit tautomerism? So first of all, you should know about what exactly the meaning of tautomerism. In this case, ketone is given. So definitely we are going to talk about the ketoenol tautomerism. Tautomerism in different aspects, but right now we are going to talk about only ketoenol tautomerism. What is the condition? What is the condition in the tautomerism? So one condition, that is condition for the tautomerism. So there must be sp3 hybridized carbon atom or alpha hydrogen carbon atom. Alpha hydrogen, presence of alpha hydrogen, presence of alpha hydrogen. So what is the meaning of alpha hydrogen? So first of all we have to understand, so this is the carbon, you can see here, this is the carbon, this is the carbon, so this will be our functional group. So those carbon atoms which is directly attached to the functional group considered to be the alpha carbon. So right now if you are going to look in the first compound, then this will be the alpha carbon, this will be the alpha carbon, in this will be the alpha carbon, and this will be the alpha carbon, and this is the alpha carbon, and this is the alpha carbon. So just have a look in the first compound, in the first one, both of these two alpha carbon having the alpha hydrogen. But if you're going to find out, these are the bridgehead carbons. So bridgehead carbons can never participate in the tautomerism. Why? What is the reason? Because these bridgehead carbon atoms, if they are going to leave the hydrogen, so definitely they will acquire double bond, but that double bond needs 120-degree. That carbon will be converted into sp2 hybridized carbon atom, so that will be 120-degree bond angle, so it will be a very high angle strain. So bridgehead carbon never participate in the tautomerism. So bridgehead carbons never participate in tautomerism. So let's have a look. All the bridgehead carbons we are going to eliminate. Okay. So these are the bridgehead carbons that we are going to eliminate. So this won't be give you, this won't be give you the, this will not be considered, this will not be considered, this will not be considered. So right now we have two options, that is second and third. But if you're going to look on the second, that is this alpha carbon does not have any hydrogen. So no alpha hydrogen, no alpha hydrogen, but it has the two alpha hydrogen. So definitely third compound, third molecule will give you the tautomeric product. and that product looks to be like this, something. This will be. So there will be, these are the two bridgehead bonds, and this will be the OH, and there will be the double bond like this. So correct answer is only 3. Correct answer is option A. There will be. So students, few students confused about the how you have chosen the alpha hydrogen. So I just want to tell you that first of all, you have to find out the functional group. Okay. So in this is your functional group, that is ketone. So you have to take in the bracket. Okay. This functional group you have to consider in the bracket. So I have considered functional group in the bracket. And those carbon atoms which is directly connected to the functional group, that carbon atom will be considered the alpha carbon. And those hydrogen atoms which is directly attached to the alpha carbon, that will be the alpha hydrogen. So in this tautomerism case, first you have to find out the alpha carbon, then alpha hydrogen, and then think about it whether this alpha hydrogen is going to be donated by the alpha carbon or not. So finally, we have understood. So only third option, this is the tautomerism concept. So we have done this one. So let's move the next question. So let's have a look. For the following reactions. So all these reactions, let me tell you, this is not a very difficult question, already asked in the NEET 2016. So this question, this beautiful question, is already present in the NCERT. Got it? So you can see this is a recently asked question, NEET 2016, not too older question. But these type of reactions, simple reactions, not a very long chain, hydrated chain, phenyl group chain, simple chains, straight chains are there. And this beauty of this question, you can see here, so many kind of reaction types. Even you do not need to perform the reaction, only you have to identify the reaction. This is the standard of the NEET, that not to ask very difficult question, only little bit memory and little bit concepts required to solve this one. So the first question you can see CS3, CS2, CS2Br. And this is the KOH. And in this, few things not mentioned. Got it? But don't worry about that. If it is chaos, so definitely you have to identify which kind of reaction it will be possible. Because if all things are mandatory, should be present in that identifying the reaction will be very much easy. So right now it is forming the alkene. So definitely it will be the if it is the forming the alkene. So it's a kind of elimination reaction. It means in this, bromine is removing and hydrogen is removing. So this is elimination reaction. In this, you can see this is bromine and this is OH negative. So what happened? Br negative is leaving and OH negative is coming. It means Br negative is nucleophile, OH negative is also nucleophile. It's a kind of substitution, nucleophilic substitution. So it is a substitution reaction. It is a substitution reaction. It is a substitution reaction. In this, you can see here, bromine is adding. This unsaturated bond is going to break and bromine is adding. It means what is bromine? It can be electrophile, it can be nucleophile. We are not talking about it here, but something is adding. So this is the common sense. So this is the addition reaction. Not so much information required to solve this question. So just have a look, elimination, substitution, and addition. So if you're going to find out, then there is only option A. Sorry, or only option D, this one. Elimination, substitution, and addition reactions. So our correct answer is option D. Even we have not applied right now organic concepts, only we applied common sense. So with the help of common sense, you can also solve these kind of easy questions. But how it is elimination? Let's have a look. So the first question. So the first compound, that is CH3, CH2, CH2, Br. So right now, students, if it is given that KOH, and this is the product, CH3, CH2, CH double bond, CH2, and it will be KBr, whatever the byproduct. So right now, students, this is the CH3, CH2, CH2, and this will be, there is 1, 2, 3. Yes, so there is only 3 carbon atoms. So there is only 3 carbon atoms. So it will be CH double bond CH2. So what happened is, student, this is the alpha carbon, this is the beta carbon. If you're going to open little bit, so this will be CH3, CH, this will be the H, and this will be the CH2, and this will be the Br. And what happened? This is, we are using the alcoholic KOH right now. So this bond is going to break towards this, and this bond is going to break towards this. So what happened? So simultaneously it will be CH3, CH, there is double bond CH2, and releases the H plus and the OH negative. This H plus and OH negative. And we have the reagent that is K plus and OH negative. So what H plus and this K plus, OH negative, and this Br negative. So it will be formed KBr and the H2O. So these ions will satisfy with each other. So this H plus is combined with this one. This Br negative is combined with this one. So finally, this is our elimination reaction. H2O along with this KBr. We found it. This is the elimination reaction. So students, this reaction is also known as beta elimination or dehydrohalogenation reaction. Beta elimination and dehydrohalogenation reaction. Also known as beta elimination reaction and dehydrohalogenation reaction. Dehydrohalogenation reaction. So in the multiple choice questions, you don't need to solve the complete question. First of all, you have solved one part. Okay. Then you can go through the options. So A is elimination. So option A can be the answer. Option B cannot be the answer. Option C and D. It means by the help of only solving A, we cannot got the idea. Let's solve the option B. So option B is, you can see here, if you are going to solve the option B, so in the option B, that is CH3, CH, this is CH3, and this is the Br. And right now you are using this KOH, and it is aqueous KOH, so it will give you CH3, CH, and this is the CH3, and there is OH. So what you have done, this is the Br negative is nucleophile. Br negative is also nucleophile, and this OH negative is also nucleophile. So it means it is a nucleophilic substitution reaction. It is the nucleophilic substitution reaction. It is the nucleophilic substitution reaction. Nucleophilic substitution reaction. That we have done it. So we have solved the second point also. Okay, so let's have a look by the help of applying both of these two concepts. Don't go with the third reaction. So first of all, apply the concept. A is elimination, B and C substitution. It means it can be the answer. A is substitution, no, never. A and B are elimination, no, never. A is elimination, B is substitution. Wow. So it means once again we have a choice between A and D. Got it? So by the help of this, you can solve the option C, and option C will be the addition reaction. So that's why final answer is option D, this one. If you are going to solve this one, this will be addition reaction, and hence we got the final answer, that is option D. So we have solved this one question beautifully. It means you can see here, reaction is already given there. Even you do not need to form the product. Product is also given there. Only it means, suppose that somehow you forget the concept about the elimination reaction, but question is already solved. Only you have to identify. It means it's a kind of matching based question. So let's have a look. Another question, another variety. So finally, which of the following statement is not correct for nucleophile? So question is based on the nucleophile. And I think it is the most easiest question in the world that had been asked by the NEET in 2015. Not a very difficult question. Question is about nucleophile. And today we are going to collect all the similar concepts like nucleophile, like electrophile, like Lewis acid, Lewis bases. All these things we are going to connect together. So first of all, I just want to tell you what is the meaning of nucleophile. So nucleophile and Lewis base both have same conditions. Electron donor. For donating the electrons, what are the conditions for donating the electrons? What should be the conditions? If they want to donate the electron, so definitely their octet should be completed. If their octet is not completed, then how can they donate the electrons to others? Definitely not. So it means Octet should be completed. Octet should be completed. Okay, that's true. That's fine. Their octet is completed, but there should be free electrons. Now, if there all the electrons are busy in the bonding, so definitely it is not going to distort its own structure and going to donate the electron to some other species. Definitely not. So first of all, octet should be completed, and the second condition, that is presence of lone pair should be presence of lone pair. Presence of lone pair. This one. So these two conditions. Okay. Let's talk about the Lewis acid, and there is electrophile. Basically, students, this phile means love. Electrophile means electron loving species. This is the most usual and most common definition in the world that we are learning since for a long time in every lecture, if a question based on the electrophile. So this is the electrophile. It means electron loving species. It means if they are electron loving species, so definitely they are ready to accept the electrons. So electrophile and Lewis acid having the similar condition. What are the tendency? Electron acceptor. These are the electron acceptor. So what are the meaning of electron acceptor? Why they need the electron acceptor? Because definitely there should be deficiency in the electrons. So what are the conditions? What are the conditions? The first condition, molecule should be deficient in electrons. It means its octet should be incomplete. Incomplete octet. Incomplete octet. But suppose that if its octet is complete, so it doesn't mean that octet is complete, so it does not want to accept the electron. If octet is complete, then you have to find out if there is any possibility to accept the electron. And how can we check it? By the checking the presence of d subshell. So the next one, presence of d subshell. Any one of the condition is satisfied, then definitely it will be the electrophile or the Lewis acid. Presence of d subshell. Presence of d subshell. So all these conditions we have discussed about this one. So let's talk about it. Ammonia is a nucleophile. So first of all, you have to figure out this is the ammonia and its octet is complete, definitely, and it has one lone pair. It's a nucleophile. It's true. Correct statement. Nucleophile attacks low electron density site. Definitely. Nucleophiles are the electron rich species, means having tendency to donate the electron. And they always giving that electron to that site or to that molecule or to that atom which is deficient in the electrons. So this is also true statement. Nucleophiles are not electron seeking. Definitely, they do not want electron. They want to donate the electron. It is also true. Nucleophile is a Lewis acid. Absolutely wrong. Opposite statement. So this is the our correct answer according to the question, because question says that which of the following statement is not correct for the nucleophile. So definitely nucleophile cannot be the Lewis acid. This will be the correct answer. Let's move ahead with the next variety of the question. You can see that not a very difficult question. All the topics are connecting. Nucleophile, electrophile are the organic concept, but Lewis acid and Lewis base concept we have discussed in the, or we are studying in the equilibrium. So that's why right now correct answer is option D. Let's move with the next question. Which of the following is not the product of dehydration? That's a very beautiful question. But I just want to tell you, whenever question is related to this one, which of the following is not, then what happened? Most of the student find the answer. They find the correct answer. But question statement is just opposite. So whenever question is related to the negative sentences, like which of the following is not the product, then you have to make an underline. This underline confirms your brain that you have to find out the wrong answers that will be your correct one. Got it? Because we are habitual to determine the correct answers. So what happened? We just find out the correct answer and then just tick it. But question says that tell me the wrong answer. Got it? So this should be in your habit. Most of the time, yes, it can be done by the students. So which of the following is not the correct, not the product of dehydration? So let's understand what is the meaning. So dehydration means removal of water. Removal of water. Removal of water. So what happens, students? This is the alcohol. You can see here. This will be. There is this one, and there is OH. So what happens, students? There is we are utilizing concentrated H2SO4 on the dehydration reaction at 433 Kelvin. If you remember it, if we are doing the dehydration of alcohol, we got the alkene, and if you are doing the hydrolysis of alkene, we got the alcohol. So students, what happened? This H2SO4, this H2SO4 releases the H plus. Got it? Releases the H plus. This mechanism you know about it. So what happened? This H plus is coming to this lone pair of this oxygen. This one attacks to this one, and it will form the dehydrated product. Protonated alcohol. This will be the protonated alcohol. This is the like this, and this will be OHH. So what happened? This oxygen will get the positive charge. Oxygen will get the positive charge, so it wants to leave. So it wants to leave from this hydrogen, and it will be like it leaves from this carbon, and this will be like this carbocation. This will be the 3-degree carbocation. Then this carbocation will satisfied with the help of sp3 hybridized carbon atom. So what are the beta carbon that we have to find out? This is the beta 1 carbon. This is the beta 2 carbon. This is the beta 3 carbon. It means, students, double bond can be present between this positive and beta 1. Double bond can be positive between positive and beta 2 and this one. It means double bond can be present here, can be present here, and can be present here. So these products can be formed, definitely. But you can see here, this can be formed, this can be formed, true, this can be also formed. But students, definitely not the correct answer. The bond is not going to form inside the cyclohexane ring. So this will be the wrong answer. That's why this is our correct option, according to the question. I hope it is clear to all of you. So this was the beautiful question that we have solved about it. Let's move on to the next question. Okay. So right now, students, the next question is the correct statement regarding the electrophile. 2017, recent question. Okay. And we have discussed about all the points. Got it? About the electrophile in the previous question. And you have to apply all these points right now. Electrophile is negatively charged species. What is this? No, I don't think so. This will be the correct answer. And can form a bond by accepting pair of electrons from another electrophile. This is true. It is going to form a bond by accepting the electron pair. But if it is the negative species, then how can it be the electron deficient? So these two are contradicting statements. So this will not be the correct one. Wrong answer. Electrophiles are generally neutral species. It is also true, some kind of true sentence. And can form a bond by accepting a pair of electrons from a nucleophile. This is also a very critical sentences. So what happens is, students, students are not going to read all the sentences. This is also the habit of few students. So they just tick this option, but this is not the correct answer. So I just want to suggest you can get the correct statement, but you have to choose the perfect answer or better answer if it is available in the option. Just go with the all options. Okay, just read the second option. Electrophiles can be either neutral or positively charged species. Only this is the difference in B sentence and C sentence. And in this, electrophiles are generally neutral species. It is not talking about the positive species. But option C is talking about the positive species also. So there is very minute difference. So I just want to tell you that try to go with the all options and then take the final answer. Okay. And can form a bond by accepting the pair of. So definitely you got the idea. You are very smart people. So definitely option C will be the correct answer. So you can see, I can give you the examples. So suppose that, students, if I'm going to give you this example, this is the BS3. So BS3 is neutral molecule. This is neutral. This is neutral, and it is an electrophile. It is an electrophile. And this is the CH3 positive. This is positive species and it is also electrophile. Positive and it is also electrophile. So positive species having more tendency to perform the electrophilic behavior. Okay, so that's why best statement, best sentence is option C. Let's go through the D option. We cannot ignore it. Electrophile is negatively charged. No, it cannot be the negatively charged. If it will be, it can. We cannot say that uh, electrophile is negatively charged species and can form a bond by accepting. No, if it is negatively charged species, so sometimes it can be the answer. It can be the option, but the best answer is option C. So that's why correct one is option C. So finally, we have discussed about this one. So electrophile, nucleophile, tautomerism, and elimination reaction, addition reaction. If you're going to work on these things, so you will be get very good score in your NEET 2019 coming years. Okay. So best of luck for your preparation, and definitely you'll get a very good score if you are going to go, if you are going to prefer NCRT first and then the NCRT exemplar books and then the other types, then go with the other kind of books. Okay, so thank you so much. Bye bye.